Today.
I like watching
Today we talk about integers.
Oh.
What are integers? Perfect. So integers are positive and negative numbers. So most of the time we did this on a number line, right? So on a number line, this is what I expect you to do on a number line. I always want you to show where 0 is. To the right, we always have what kind of numbers? Positive, right? So we start putting our little slashes and we put positive numbers. To the left,
Negative.
same thing, but negative numbers, right? So this is what I would expect of you if you do this. And then we know that because there's arrows at the end of our number line, what happens? It keeps going on, right? So we got all the way to, what do I call this way down there? If it keeps on going out, what?
Infinity.
Infinity. What's the symbol for infinity?
Oh, it's like an A on its side.
Perfect. So it goes all the way to infinity, right? And then, obviously, if we go back to the other way, you gotta turn your paper.
I can't draw like that.
I can't really turn the board, so I had to learn how to do it. Oh, that's all right. You can practice. So then, obviously, if we go in the other direction, though, we go into negative infinity. So if they talk about a set of numbers, or if they want you to show the set, remember, sets can be shown inside those curly Q brackets. So for my integers, I would show 1, 2, and then dot, dot, dot. Or if I go the other way, we'd have -1, -2, dot, dot, dot. What's dot, dot, dot mean? So pretty much the same thing, right? As infinity. It just keeps on going. So it's just a different way of saying it. Alright? So why do we have integers? Well, we do this sometimes because we want to use positive and negatives to describe certain situations in the real world. Now, is every single time that something's negative, is that necessarily a bad thing? When would you say a number that has a negative would actually be a good thing? Okay, if I'm cutting down my amount that I owe somebody, what else? When does a negative number not show a bad thing? Anybody play golf?
Oh.
Right? So the people that have negative numbers are winning the tournament, right? They're really, really good. Positive numbers in that case are actually bad. Maybe we're talking about our bills, like you said. Okay, so my electric bill went down, but I would say that was a negative. But that's actually a good thing, right? So how about the other way? When is a positive number not a good thing? Golf again, yeah. What else? Bills in that case, right? What else?
In your fridge.
Interest. Interest is a good thing, right? But it might be bad interest. If you had a bill to pay, you have to pay interest. So they might raise your interest rate. Okay? So, positive or negative? If I said 32 feet under the ground, we'd have negative 32, right? 8 weeks after birth, it'd just be a positive, okay? So here's another good thing that you just brought up. With positive numbers, do I ever have to write the little positive sign? No. Can I? Yeah, but not anybody really does it, right? Do I have to write the negative?
Yes.
Yeah, because that shows everybody that it's negative. Okay? How about a loss of 6 pounds?
Minus 6.
This is a good negative, right?
Yeah.
Okay, well, maybe it is. Again, now that could be a little thing too. I mean, if you're, you know, a little person, meaning not size-wise, but like a young person, you might not want to lose 6 pounds. A baby losing 6 pounds wouldn't be a good thing. Yeah, right? So that minus 6 pounds kind of is, you know, maybe half and half. Okay? So how do we use integers? Well, we can use integers by plotting points on the number line, right? So if somebody says, I want you to plot a couple of numbers, and they give it to you in a set. They give you -4 and 7, okay? And they ask you to plot that. This is what I expect you to do. So again, I'm going to draw my number line. I'm going to again draw and show where 0 is. I do not expect you to count out every single line, or every single of the little slashes. Because if these numbers are really, really big or really, really small, you could have a ginormous number line, right? So in this case right here, I just want you to show me that you know where a positive 7 is compared to 0, and then put a dot on it. Okay? You don't have to do all the little slashes. That makes sense? And then -4 is obviously over here. And I would put a negative and put a dot there. Simple enough. Okay? Then we start talking about integers and inequality signs. What are inequality signs? Perfect. Okay? So, and then what else? Then we have the same ones, but we also have what under those?
Greater equal.
Yeah. So, here's the question. Everybody take a second and think before you answer this. What's the difference between this one and this one? So they're both less than, but the second one has an equal sign under it, so it's less than or equal to. So what's the difference?
Well, when there's no line, it means that it can't be less than the other number.
It can't be equal to.
It can't be equal to it, right? It has to be less than the other number. It's less than it, right? But if I'm comparing two numbers now, so this is, I can use this either with variables or without. Meaning I could use it with variables and then we'll actually graph those kind of problems. Or I can do it with just 2 points and showing what's bigger or what's smaller, right? So if I do it that way, when I'm comparing two numbers, how do I know what sign to use? I always like to say it points towards what? The little sign points to the smaller one, to the smaller number. And it looks like it quote unquote eats the bigger one, right?
Yeah.
So again, if I have random numbers, 8 and 14, and then maybe they put a line here, maybe they put a box there, maybe they put a circle there, that can change all the time. But I'm filling in my gap with one of these things, my inequality signs. So obviously, which one's bigger, 8 or 14? 14, right? So again, it's going to point towards the smaller one and look like it's eating the bigger one, so I'm going to have 8 is less than 14. Now here's the other thing that I would get used to, okay? How do I read them? Yeah, so when you do this, again, try to read from left to right. Because is it wrong if I would say, in this case right here, that 14 is greater than 8?
Not wrong.
No. But if I looked at it, that might confuse people because 14 is over here. So just make sure that you get in the habit, and this is where I would say if you start using variables, that you always put the variable first or before the sign so everybody's reading it the same way. So this one is actually 8 is less than 14. But it really means the same thing as 14 is greater than 8. Okay? So then obviously we know that if I have a negative number and I have a positive number, do I even have to really think about it? Which one's bigger? Always my positive numbers, right? And then obviously, if I have 0 involved, if I have positives, the positives are always bigger than 0, but the negatives are always smaller than 0. Okay? So we can use that, and every once in a while, they might put this sign right here. What's that sign right there mean? Not equal to, right? Not equal to. Okay? Any questions there? Then we can try to order the numbers. So put numbers in order. And there's 2 ways how we can do this, right? From least to greatest, or obviously greatest to least. Now, in math, especially when we get into like geometry and stuff, they might use another word. Any idea what it means? If I'm going from least to greatest, am I going up or down? Up, right? What's another word that they might use in math instead of just saying, I'm going to go least to greatest? Any idea? It begins with an A. Adding would be kind of what we're doing. So that's not a bad idea, but that's not the word I was thinking of.
Abstract.
Don't speak.
I don't know if you've ever heard of this word.
Ascending.
Ascending order. You ever heard of that?
Close.
And so what's the opposite if I'm going from these? Yeah, so you might hear these a little bit more in math. Instead of saying least to greatest or greatest to least. Okay? So if that happens, just make sure that you understand what those mean. So again then, if I'm putting them in order, I can always go back to my number line and think about putting all those numbers that they give me in the problem on a number line, and then I can order them. Or if you just understand how it works, I can just go ahead and do them. So examples of this. The temperatures in January for Iowa, or whatever it happens to be. If you want to get specific, maybe it's Lamar's. Are -8 degrees, 10 degrees, 2 degrees, -3, -11, 0. Okay? So, can I put these in order from least to greatest? Alright? So, what's my smallest or coldest temperature? -11. Then what? Zero,
2,
2, and 10. So, the most important part of this is to make sure that in your answer you got as many numbers as there were in the problem. So 2, 4, 6, 2, 4, 6, I got them all down. So it should be right. Okay? So again, nothing real complicated today, but we're just showing you that you can use positives and negatives to do certain things. All right. Last thing that we're going to talk about today are absolute values. What's this mean to you? Remember what absolute values are? Okay. So they're shown inside vertical bars. So something like this, and then they'll have a number inside of it. Okay. So what does this mean? What do absolute values tell you about that number, though? Okay, there could be a negative to it. But it says that my answer is going to be positive. But why positive? Why is it positive? Okay, yeah, because of the little bars, yes, it makes it positive. But why is that? It's because when you talk about absolute values, you're talking about the distance from 0. Okay, so if it's a distance, anytime that you, from here on out, talk about a distance, it's automatically gotta be a positive answer. Because even if I stand here just like this and I walk forward, you would all agree that I went a certain distance, right? But if I walk backwards, you would say, well, you went in reverse, so that should be a negative distance, but it's still the same amount that I covered, going forward as backwards, right? So any distance, even though it looks like I'm going in the opposite direction, is going to be a positive, and that's why this works. Because if you think about this on our number line, and let's use 4 instead of 8 like we had up there, and we put a 4 or a dot on 4 and a dot on -4. From 0, though, it's the same distance going to the right as it is to the left. Would you agree? Yeah. So every single time Landon was kind of right, again, we just say kind of because it's Landon, but it's a distance from 0. That's why every single answer, as long as it's inside of my absolute values, has to be a positive number. Okay? And so if we have negatives, the absolute value of -7 is 7 because it's still a distance of 7 spaces from 0. All right. This can work with variables. They can work with a lot of different things. So obviously we go through a few of these problems. The absolute value of 5, what's my answer? 5. So remember back when we were doing expressions and we talked about the order of operations? PEMDAS, right? The P was my what? Parentheses. These actually act kind of like special parentheses. So you want to always do absolute value portions of a problem before you carry on and do the rest of the problem. Okay, so for instance here now, if we turn this so Chance can see when he watches this, and Brady's in camera now. So what do we get with the second one? With the second one, it says the absolute value of -8 plus the absolute value of -1. So we get 8 plus 1, which is 9. No negatives, right? Drop the negatives, because again, remember, every single time that I get an answer out of there, they always got to be positive. So then we get the absolute value of negative, throws the negative away, and we get 8 plus 1. Okay? Next one over to the right. 2, right? 6 minus, that minus doesn't, the one in the middle doesn't get erased. It's always got to be in the problem. Okay? How about over here, the one that starts with 9 plus? It is confusing with this part right here. So we're going to put -8 into our absolute values with, or where the A is, and so we get what? 17. Exactly right. So the -8 becomes +8, and 8 plus 9 gets me my 17. Okay. How about here? What happens if I have a number outside in front? It just means times, right? It's just like having parentheses around that, right? So we have -8 here. So then we first have to do the absolute value of -8, which is +8, and then we multiply them together, so we get +16. So we're still doing the order of operations, right? PEMDAS, like Michael said. But absolute values really are a special set of parentheses. Okay? Questions? That's it. You get the rest of the time to work. You might get this done before you leave today. Then you won't have anything to worry about all weekend, at least considering math. All right? So, we get out of here, 26, so you got, like I said, you got lots of time.